Hello friends, welcome to session 6 on orthographic projections. These are all offline video help files prepared by me, Dr.B.Gurudatt, former professor and head, Department of Mechanical Engineering, Bangalore Institute of Technology, CAED Road, Bangalore 4, presently working as professor at the Department of Mechanical Engineering, Nittai Meenakshi Institute of Technology, Elanka, Bangalore 64. Now we'll continue with machine components. Okay, as usual, I have shown on a typical machine component in isometric. Okay, you are supposed to draw the front view, top view, and the side view. Here, the direction of front view has been given. You take this as the direction of front view, draw the front view, and top view of course, you have to draw. And since left surface is predominantly seen, compulsorily you have to draw the left view on right profile plane. Always please understand, when you are looking from the front direction, you have to imagine VP to be behind this object and your direction of vision is perpendicular to VP. Okay, that means at least in a rough way you can understand that VP, when it is behind this object, it will be parallel to this because your direction of vision is perpendicular to VP. Okay, behind this object you imagine vertical plane to be there. In the same way, when you are looking from the top here, below this object, okay, imagine horizontal plane to be there. When you are looking from the top, the direction of vision will be perpendicular to the horizontal plane which you imagine below this. Okay, in that way horizontal plane will be below this object, and when you are looking from the top direction here, the direction of vision will be perpendicular to HP. In the same way, if you are looking from left, okay, that is left view, no? Left view, you look to the, that is the left view, we write it on right profile plane. Okay, the left view, we do it on right profile plane, and the direction of the left view is also perpendicular to the right profile plane. Okay, in that way, whatever surface, let us say these surfaces and all that, will be parallel to the right profile plane. Okay, if a surface is like this, it is clearly, unlike this surface, at least this surface is parallel to the right profile plane. Always remember, front view is this. They might give the front view this way or this way. If they give this way, imagine VP to be behind this object. The direction of vision of the front view is perpendicular to VP. In the same way, for writing the top view, imagine horizontal plane to be below this object, and the direction of vision for the top view is always perpendicular to HP. In the same way, when you are looking from left view, that is when you are looking from the left, okay, the right profile plane is assumed to be behind this, and the direction of vision for the left view, okay, is always perpendicular to RPP. That is the basic thing what you have to understand. Okay, now you see here, it's a typical problem what you can expect in the exam and all that. Okay, carefully observe. This will be the problem given. Okay, the problem given will be this: the isometric view, isometric object will be given. Looking at the isometric object, okay, once the object is given with all the dimensions and all that will be given, this will be given. And I have told you earlier also, in case any dimension is missing, you can assume it. Okay, assume, and at least in this problem, I don't think there are any dimensions missing. Everything you have to search somewhere the dimensions will be there, that you have to take care properly. Now, as usual, as I just now said, it is the front view direction is this. Then when front view is this, you have to draw the top view and left view. Okay, front view on VP, top view on HP, and left view on right profile plane. That is why looking at this, okay, you immediately start with XY, X1, Y1. VP for writing the front view, HP for writing the top view, RPP for writing the left view. Please understand, that is RPP, I made it ready to write the left view on RPP as per the first angle projection system. Okay. Now you carefully see here. Let us say I want to start with the front view. If the front view has to be this way, see here, the VP is just behind us and the direction of vision of the front view is perpendicular to VP. As a result, this entire thing can be seen in its true length. This entire thing can be seen in its true surface, only the view and all that. We'll write it as it is. Okay. Now you see here, this, as you see here, this distance is, this is 40, okay, plus 10 plus 10, 60, okay. That means, and this distance is also 10. Please follow. This distance from here to here is 60, okay. This distance is 20, okay. This distance is 10. This distance is 40. At least with those things, at least we can complete this portion, okay. See here, I have drawn this. This is 60, as I just now said. This is 40 plus 10 plus 10, 60. Then draw this 20, okay. Draw this, and this is 10 mm. This is again 10 mm. Go here up till here. Again, this is 10 mm. Draw this, and at least this front view of this portion is completed. You have a fold. We'll come to that later on. Okay. Then you have this portion again. Since this is also parallel to AP, the same thing can be done. As you know here, from here to here is 55. From here to here, you go 55. Okay. 20 already done. From here to here, you go 55. Then you have one chamfer here. This is called chamfering. Okay. At the end, no, this total distance is 60. 15 you leave it off. And 15 you leave it off here. I have given that because it is 55. This distance, if you see here, this is 40. That means from here to here is 15. And this is also 15. That means leave off 15 here, leave off 15 here. In that way, you are completing the chamfer portion also. Darken this portion. Is it okay, all of you? Okay. This is 55. Come till this. That is this portion I am writing. Okay. This portion I am concentrating. Okay. In that way, leave off 15. Leave off 15 here also. You complete this. Okay. Once you do this, you have a fold of diameter 20 at the center. Okay. It is, if you see this fold, no, it is centrally placed. Circular fold. This is 55. It is 27.5. Okay. What you do is, you take to the center line, that is alignment indicator or whatever it is. That means if it is 60, at 30 you go up, and from here 27.5 from here. From here 27.5, make a dot. Okay. With that as the center, you draw a circle of diameter 20. Okay. Once you draw the circle of diameter 20, that fold is completed. Fold is completed in the front view. We'll come to this fold later on. Okay, now what you do, once you do this, more or less the front view is completed except this fold, okay, in the front view. This will, I'll tell you how to exactly to do that. Okay, now what you do is, once you do the front view completed, come to the bottom. Okay, this distance can be anything, as I said. Whatever is this distance, you take this distance also, same thing. Okay. You take some distance here. Okay, it's some 30-40 mm, you leave it off. If this is 40, you leave 40 here also. If it is 30 here, leave 30 also. This is anyway distance in front of VP. That can be anything. Or whatever may be the distance here, your used will not change. Okay. Now, you are leaving some distance. This is the distance in front of VP, correct? Okay, because when you are looking from here, VP is behind this. This will be the distance in front of VP. 40 will be the distance in front of VP. 40 you take it here. Okay, 40 you take it here. And this distance anyway is 60. In that way, 40 by 60 rectangle you complete it off. That is very important. First you complete the rectangle. Once you complete the rectangle, you see carefully. Now, once you complete the rectangle, you write the fold here. This fold is 12.5. That is, from here, at the center it is located. At 12.5 is the center. At that center, you draw a circle of diameter 10. Okay, diameter 10 you draw. In that way, if you take the projectors up, in the front view also, this dotted line if you show, okay, the front view will be completed. along with this. See here, because when you're looking from here, this fold in the front view cannot be seen. It is invisible. The edges of the fold will be invisible. That is why, but in the top view at least this circular fold can be seen. No, in that way, I'll draw the circle in the top view, take the projectors up, okay, and I'll show this portion, the pole is in this portion, okay. That means you show dotted only here, okay. Now once you do this, you see here, you are drawing the top view. You are looking from the top, okay. You are looking from here, and as you are aware, this edge which is going inside, this edge which is going inside cannot be seen. That means 10 mm, 10 mm it is it. Okay. When you are looking from the top, those two edges cannot be seen. That is, this edge going inside, this edge going inside cannot be seen. Okay. Now that 10 mm, see here, this is 10 mm, this is 10 mm. In that way, I have shown one dotted line here, I have shown one dotted line here also. Please carefully observe these dotted lines. You have to represent, otherwise you are losing mass. The dotted lines play a crucial role. Then only you can understand how the solid is. Okay, this surface is a vertical surface perpendicular to HP, correct? No, this is perpendicular to HP. When you are looking from the top, this is obstructed by the solid. This vertical surface will be seen as a line. In that way, this particular thing, you should make it dark dotted. Even this edge, this is vertical surface perpendicular to HP. In HP, it will be seen as a line. Otherwise, also you can see that this edge going inside, this edge going inside, and all that, when you are looking from the top, cannot be seen. In that way, you make it dark dotted here, dark dotted here. Okay. Then you see here, you have drawn a fold here. Okay, you have drawn a fold here of diameter 20. Okay. Once you have drawn a fold, that top view, in the top view, you cannot see this fold. That is why you take a projector down. In this portion only you have the fold. Correct? Only for 15 mm. 15 mm. Okay. This fold is this fold, circular fold is only for 15 mm. In that way, you take the projector down and show only in this portion dark dotted, dark dotted. In that way, front view and top view has been completed in all respect. Okay. Take care of this dotted line. Take care of this dotted line, which is representing this and this. Take care of this dotted line in the front view, that is this dotted line. Take care of this fold in the top view, okay, that is this dotted line and this dotted line. Okay, then we'll draw the left view and right profile plane. Okay, when you draw the left view and right profile plane, you see here. Okay, when you're looking here, you draw, this is anyway 40 you take it. Then you take the projector from here only, you draw this anyway is, as you know, this is 15, this 15, you come down up till here, okay, that is up till here 40, totally 75 minus 20, 55, 55 you come down, okay, 55 you come down, then you draw this is, of course, this total distance is 40, this is 15 means this will be 25. In that way, this outer boundary first you complete. Okay, this is 15. As you're looking from here, this is 15. That is, this is 15. And if you come down, this totally is 75. Come down to 75. And this is in front of VP distance. Okay, leave some distance here, whatever you leave. This is anyway, with reference to this point, it is 40. Okay, that means this, from this 40, you take this 40. And this distance is, as you know, it is 20. Okay, 20 it is given. This totally it is 40. This is 15 means this will be 25. In that way, you are able to complete the left view. And this edge, when you are looking from here, you can see this edge. That is what I have darkened here. And when you are looking from here, this fold cannot be seen. I have made this as dark dotted. Okay. And again, when you are looking from here, even this fold also cannot be seen. Okay. This fold you show dark dotted here also. Okay. Dark dotted here in the side view. Okay. That means at a distance of, you know very well, at a distance of 12.5 you take one dotted line here to a distance of 5 mm. In that way you show. Okay. In that way we come to the end of session 6.